Okay, so the last videos has been about the basic structure and the syntax in Swift. We're going to take a step further and talk about objects and object-oriented programming, which is basically the thing we've been starting out with. Swift is a great example of this, but what does that actually mean? If we look it up in Wikipedia, it says kind of like this. Object-oriented programming is a programming paradigm based on the concept of objects, which may contain data in the form of fields, often known as properties, and code in the form of procedures, often known as methods. What does that actually say? Well, when it comes to programming language, there are some old ones that are not really object-oriented. But most of the modern languages are object-oriented. And that is basically saying that everything you do has to do with objects. So, for instance, if you think about a game where you have a car that you might be driving around, the car is an object. And the object has properties, colors, speed, and so on. And of course, it has methods, which is things that it can do. So let's start out with the most basic thing, instances. We've been using this quite a bit already. So when we create a variable like this, string variables in this case, they are actually instances of some type. In this case, these are string instances. These are both instances of the same type string. We can think of the type string as something of a blueprint for all the strings that we create. The blueprint actually tells us exactly how a string is constructed. And it has some properties and it has some methods. And also another thing we have to talk about in this case is initializers. So far, we've created instances by giving them the variable a literal value like this. So this is one string where we put banana into it, and there we have integer, and both of them are so-called literals. This works for some types, but not all. It works for strings, and it works for integers and booleans and so on, but there are actually types that it won't work for. Even if it works, like with strings, you could also use the more normal method where you actually use the initializer like this. Sometimes you add parameters, like in this case with the date. Like you can see here, you have string, it's basically the name of the type, and start and end parentheses, and also the same with the integer. These two are initializers, and what they do is they actually create a new instance of the string type and put it into this variable. The same thing is done down here, but here we also give a value. So if you just call date without anything in the middle, that will actually give you the time right now. But if we do like this, so we say date and then time interval since now, 1800, that will give us in half an hour. I mean, actually the time half an hour from now, because these are actually the amount of seconds from now until the time we're talking about. So this seems like some kind of a function, and definitely it is a function, but there is actually some differences. Initializers are a special kind of function. They look kind of the same way as a normal function, but there are a few differences. First of all, you call it with the name of the type, starting with a capital letter, like this. So it says string or int, like this. Always when you define a normal function, you start out with a normal letter, not the capital letter. In this case, I've done just a small function, add num, with two parameters, and it returns the sum. So I can call it like this. You can't actually use initializer this way. So an initializer always returns a new instance of the current type. So you can't call it this way. So if you try to use this kind of code just by itself, it won't work because these two are initializers and you have to use them this way, where you actually put the output from the initializer into a variable. Okay, so how does all of this work then? Could we construct other kinds of types? I mean, we've been talking about strings, integers, booleans and stuff. Could we actually do new types, new kind of objects? Yes, of course we can. Let's think about a person. Let's think about a type that we call person, a really simple type. The only thing that we will add to that type is its mood. We'll create two persons, a sad person and a glad person. And we use the initializer person and we send a parameter into it with the mood like this. So we get a sad person and a glad person. So these are actually two instances of the same type, person, a new type that I have constructed somewhere. I haven't shown you how that is done. We'll talk about that a bit later. So we have two instances of the same type, but they have different properties. Mood is a property that we give it when we initialize it. So in both cases, we use the initializer, person, mood, and then what mood it has. Okay, so we'll talk a bit more about properties and methods. So an object has two really important parts. The first one is properties, and here we talk about values, attributes, like a person's mood, a person's gender, a person's weight, etc., etc. If we talk about methods, that is more like things that an object can do or perform, kind of like function. It could be actions for a person, like run, sleep, etc. But how do we access these properties and use these methods? Let's look at the string variable as an example. So here I've constructed a string, and then I'm using this is empty, which is a property. I write my string to bring up the variable, and then I write a dot, and then I'll get lots and lots of alternatives to pick from, and is empty is one of them. In this case, this property is false, and it is a property. Next line, I write my string dot, and then I pick remove all, and as you might understand, that will remove everything from the string and just leave an empty string. This is an example of a method, something that the string can do. And then I'll just try this one again. And obviously, because of the fact that I've taken everything away, my string is empty will give me the answer true. And this is also a property. So entering a point at the end of a variable brings up all possible properties and methods in a list. Okay, so let's try this a bit in a simple exercise. So you could open a playground and create a few string variables and insert one of the variable names and insert a point at the end. Here you can use different methods like remove all or has prefix, which is actually a method that checks out if a string, you can see it here, has prefix, and you add a string. This will look through the string and look if the string that we're attaching that to actually starts out with this string. Of course, you have another method that does basically the same, but it checks if it ends with a string instead. So that is has prefix, has suffix. Two simple examples that will give you a boolean as a result. Also try to use the method remove all and then verify that the string is empty where the property is empty. So try these out, play around a bit, and if you want to, you can tag along a bit and I'll show you how that works. I've prepared this, so I have a few strings over here, string 1, 2, 3, 4. I'm declaring them, and then I've done what I told you to. So I've checked is string 2 empty? No, it's false because string 2 is not empty. And then I take string 3 and I remove all, which will actually return an empty string. So it actually does empty string 3, but it also actually returns that value. We'll talk a bit more about this later on. And then I'll just checking, is it empty? Yeah, of course it's empty. And then I've tried the function has suffix. So I'm writing string 2 has suffix string 4. So I don't have to actually add a string into here. I can use a variable. I'll add just one more line and I'll try string 1. When I enter the dot, you see all of these possibilities. And if I want to pick one of them, just mark that one and push enter. But I could also start writing. So if I want to have has prefix, I just start writing it and I will be able to pick it. So it actually filters out the function or the methods or the properties that is starts out with these letters. So I just tap enter and I can enter the string. So I could just say, does it start with hello, and misspell it? And it will say no. Okay, so if I spell it right, it says true, obviously. While we're in here, I could tell you a bit about how to get some help with the syntax and stuff. When you use the dot notation, you get quite a lot of help with what things you can add, like properties and methods and stuff. But if you just want to know something about like remove all, hold down Option on the keyboard and put the mouse above something that you want to know a bit more about and just click. So you'll actually get the declaration and some information about this. And if you want to read more about this, you could just click one of these links, depending on what you want, and it will show you the documentation about this. If you want to, you can also use the buttons at top right and show that one and mark the question mark, and then wherever you're standing, you'll get the quick help out here. So if you're standing in a string like this, you get that help, and if you're standing in like is empty, that will be shown over here. Actually, the thing I like to use is the alternative and the question mark, and just click on stuff like, is empty, for instance, and it will tell you a bit about that, which is just great. If you want to get this help and search in the help a bit more thorough, you could always go to Window, Documentation and API Reference, and then search for something like remove all. So you get everything that starts out with remove all, so you can just check this out. Okay, that's it. Okay, so that was exercise 7. We have a few more things to say about this, so let's go on. When you look around in the reference, you might notice there are 2 kinds of types. We have something called a struct, which is short for structure. It holds info about values like strings and integers and similar things. So here I've constructed a really simple struct called location. You can think about like in a coordinate system, this is the location of a point. So I have 2 properties, x and y. A variable of a struct is holding the actual instance inside the variable. So if you change something in the variable, it's actually the variable changing. So we'll talk a bit more about this later. Then we have a class, and that can be information about more like real objects, like a person or a car or something. So I've constructed a simple class over here called person, and these persons have 2 properties, name and home. And when you have a class, We'll talk more about this later, but you have to have an initializer defined then, at least one. And it works like this. You have these two properties declared, and in the init you have name and home, and these are actually the values that will come in when you run the initializer. And the basic idea is to take name and put it into self.name and home into self.home, which actually means that because self is the instance we're talking about, so the instance dot name is referring to the property name for this particular instance, and into that we put the thing that the value that we get when we initialize. So that is actually the thing that's happening. When you initialize, you put this value into this. It works kind of in the similar way with a struct, but here we don't have to write the initializer. It will work the same, but we don't have to define it. When we do a class, we have to define the initializer. We'll get back to this and talk about this really in depth later on, but just to get a hang of it, I'm telling you right now. There's a kind of odd thing though with a class. It actually just holds the reference to the actual instance in the memory, not the real instance, and this actually means quite a lot, and I'll just try to explain to you what I mean about this. So what does this mean actually? Let's see. If we have a struct, if we have two instances, so for instance our location here, I've defined one here and one here. If I say, okay, let location 1 be assigned to location 2, then I change the value of x for location 1 to 2. What happens with location 2's x value? Well, because location 2 got the x value from location 1 up here, it is 0. If I change the x value for location 1 down here, that won't affect location 2 because all the data lies inside the variable. So x chord will still be 0. But with classes, it's quite a different thing. So if you do the same thing with two instances of a class, both will change. So here I've defined person 1 and 2, and they have different locations and different names. If I say that I will assign person 1 to person 2, what I'm actually saying is not really copy the information, it's more like I'm telling person 2 to actually look at the data that defines person 1. So they're actually pointing at the same data. And that means if I now change person 1 like this, the name of person 1, because of the fact that these are variables just pointing on data, of course, person 2 dot name will also be changed into Fred. So this is quite a big difference. When you do this kind of assignment with a structure, a struct, you copy the information from one to another because the information is actually inside the variable. But if you do the same with a variable of a class, that is not really true because you're just telling person 2 to point on the same information as person 1. So that's the reason this happens when you change it. Okay, this is a bit difficult, might be, but let's look at some kind of exercise here. The basic idea is to use the code 2 slides back, where I defined the location and the person, the struct location and the class person, and then add a method, a function in the class definition after the init. So this is a method. You should call the method move, and use two parameters for movement, dx and dy, both integers. And then let the function add dx and dy to the x and y property using the syntax to the right with self. You might remember from the last example. So self.home.y, to that you should add dy. And then use the new method to move one of the person's home location. Okay, you might want to try this yourself first, but if you want me to explain it for you, I do it right now. So here you have the struct defined the way I did it in the presentation with two properties, x and y. And then we have the start of the class for person. So I have name and home string, and home is the type location, which is taken from here. And then I have the initializer that takes two parameters, name and home, and I move the data from the initializer into the actual property this way, using self, that is referring to the instance itself. And then your task was to add a method. So I'm doing that right now, just below the init. You have to have the initializer first, and then you can add methods. So it's a normal function that takes two parameters, dx integer, dy integer, and what it does, it calls up the x value of home and adds dx, and it does the same with y. Down here I have created two locations. Down here I've created two person. The first person, I'm just using the location 1 from above, but at the second person, just that so that you know that this could be done, I'm actually using the initializer implicit like this. So if I do this, it will actually return a location, and that will actually do basically the same thing as this. Apart from that, I'm writing it directly like this, so I don't have to do the variable first. I can just write it like this. If I'm now telling the program that person 2 should be pointing at the same data as person 1, if I now check the x-coordinate of person 2, that will give me 0, because of the fact that person 1 had the value 0. If I now use the move function to move person 1 like this, person1.move, and I move it 5 units dx and 10 units dy. Actually, both of these are changed. The best thing to get a hang of this is to play around with this simple example and try to get a hang of the difference between a person and a location when you change the data. So that's it.